Hello, my name's Ian Goulding. I'm an international expert in food safety, working for the EU-funded project, the EU-Sri Lanka Trade-Related Assistance Project. This is a second presentation in a series of presentations on food safety, and this one deals with food safety control systems and concepts. Others within the series, already I've spoken about food safety governance. Later on I'll be speaking about the socio-economic costs and benefits of food safety, particularly in Sri Lanka, and also about the proposals that our project is making for the reform of the system. So when it comes to the regulatory system for controlling food safety, how do we use laws and regulations to make sure that something as intangible as the safety of food is actually controlled? Well, broadly we have a choice of two kinds of model, really. In this slide we see that there's a process where you take a raw material, put it through a process, and you have a final product. And essentially, our choices are to look at that final product, and maybe we do some form of evaluation. We can use our senses, or we can take a sample and test it in a laboratory, and use that information to make a decision about whether it's safe or not. Or we can look at the process, and we can control the process parameters. Both have been used, both are in use in different countries, and very often we use a combination of these two approaches. So end product testing is, as the procedure, is a common method, and there we have to take a sample from the batch of food. We analyze those parameters in that sample, one way or another, using a laboratory or some testing method. And then we compare the results against a standard to see if it meets the standard. Of course, we make an assumption here that the sample we've taken is representative of what is in the consignment whose safety we're trying to determine. If the sample passes, it meets the standard, then we accept the consignment. We may issue a certificate. If it isn't, if it doesn't comply with the standard, then we make the assumption that the consignment is substandard and non-compliant, and we reject it. This model of end product testing is what many people consider to be the food safety system. But one of the problems with this approach is that, as we can see from this table, we are limited by the statistical nature of the sampling process. So if we just make an assumption that if we have a batch with 25 units in it, and one of those units is non-compliant, because this is the thing about food, is it doesn't have to be every item in the batch which is bad. It could be one item which has got those bacteria on it that infective food worker put their hands on without going to without washing their hands after going to the bathroom, for example. So the hazards are not uniformly distributed in food. So what is the probability of actually identifying that non-compliant product within the batch of 25? Well, if we just take one sample, the probability statistically is only 4%, 1 in 25, that we will find it. If we take two samples, that doubles to 8%. Even if we take 5 samples, we only have a 20% chance of catching the problem. That means we only identify the problem 1 time out of 5 sample runs. In other words, 4 times out of 5, we get a negative result and go to the conclusion that the product is okay. Yet there is a dangerous defect. So the level of protection conferred by end product testing is not sufficient for us. It doesn't do the job. We need more. The other problems with it is it's retrospective. It doesn't control quality, it only measures quality. So we need to go back, once we get that result, we need to go back and do something about it. But by that time, maybe the product has been sold or consumed. We get a false sense of security because a series of results tell us there's no problem, therefore we think everything's okay, but we know that maybe it isn't. It's very expensive. We need lots of laboratories, analysts, and to get accurate results, this costs a lot of money. And even then, analytical techniques are imprecise. There are false negatives, false positives to any test method. So using end product testing, while it does give us some information, it only has limited effectiveness in controlling highly variable hazards in a biological system. And because of the high level of sampling and testing required to achieve certainty, this imposes a very high cost burden. So we can't rely on it, we need something else. And that's where process-based controls come in, because with a process-based approach, what we do is we look at the whole process, we identify the food safety hazards which can arise, which could realistically arise in this process, determine the conditions in which they might be present, and then select those, ensure that those process conditions either eliminate or minimize that hazard. And then we monitor those processing conditions and with a measurement method and limits on the monitoring criteria. And therefore, when we see the process conditions moving outside of what we have determined is safe, we can take corrective actions. And these are the principles of process control-based systems such as HACCP, Hazard Analysis and Critical Control Point approach, and also embodied in the ISO 22000 series. The problem from a regulatory point of view is this requires a well-informed inspector at the point of production. So it's not quite so simple as taking a sample and giving it to a lab for testing. You need inspectors who understand hazards, how they arise, and how to control them. So it needs a higher professional level of skill and knowledge and expertise in the inspectors you are recruiting. This slide just shows some of the differences. So between the mandatory certification and product testing and process-based controls. As we see, the control method is different, as we've explained. The role of the inspector moves from sampling and sending products to a laboratory to inspection of premises, process, and HACCP. And the enforcement is less focused on the product, rejecting a batch or refusing to give a certificate or something like that, and more towards ensuring that suitable controls are in place within the establishment. And underpinning this approach is the risk-based approach to food safety controls. We mentioned risk in the previous presentation. Risk in the food safety context means a function of the probability of an adverse health effect and the severity of that effect. And the overall system of establishing a control we call risk analysis, which has three components: risk assessment, risk management, and communication. Risk assessment is where we identify the hazards and characterize them and try and assess what kind of health effects might be derived from different levels of exposure. Risk management are the policy alternatives for how we actually control those hazards based on a risk assessment. Are we going to use regulations, or can we use advisory measures, or are there some other kinds of controls we can apply? Where should we apply them in the supply chain, and so on? And risk communication is the exchange of information about the system. The challenge for governments is how to organize institutions to be able to deliver this rather conceptual approach. There is a very important set of guidelines published jointly by the FAO and the World Health Organization, the Codex Alimentarius, which is principles and guidelines for national food control systems, which, although is a little bit out of date now, it gives us some good indications on how institutionally governments can approach these issues. So that's it for the approach to control systems. For more information, please don't hesitate to contact our Chief Technical Advisor or myself at these email addresses for any further information. Thank you very much for your attention.